So like configurational and conformational. So this how hello everyone, welcome to Plutus STEM. So we were discussing regarding the organic compounds, their classification, and today we are going to discuss about the isomerism of these organic compounds. So before going to the detail, we need to know what is an isomerism. So it is a phenomena over which we will see the certain compounds are there that possess the same molecular formula. Same molecular formula. The molecular formula is going to be same. So if there is anyone who doesn't know about what is molecular formula, so it means how many constituent of elements are there, that the exact number of that is being termed as molecular formula. Like if we are having, this is our compound CS3, CS2, CS2, CH, OH, like this. So if you see this compound, if we want to know the molecular formula of this compound, so we can say over here 1 carbon, 2 carbon, 3 carbon, 4 carbon. So carbon numbers are 4 over here. How many hydrogen are there? 1, 2, 3, 2, 5, 2, 7, sorry, 2, 9 or 1, 10. C4, H10 or 1, 11. C4H10O. Clear or not? 3, 2 to 4 to 6, 3, 9 or 1, 10. So H number is 10 and O is 1. So we write it like C4H10O. This is the molecular formula of this compound. Clear? So we can have some other example regarding this. I am just taking the simple example only. CS3, CS2, O, CS2, CS3. So if I ask you regarding the molecular formula of this compound, carbon 1, carbon 2, carbon 3, carbon 4. Clear? Hydrogen number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hydrogen number is 10. And regarding the oxygen, again the 1 oxygen. So if you see both these structure, they are having same molecular formula. Molecular formula of both these structure, if you are seeing, so these two are quite different structure. And the previous video we have already discussed regarding some functional group also. So this is an alcohol functional group where the OH group is present, and this is an ether functional group. Ether. So these are two different functional groups, and we know they possess the different properties. In the previous lecture, we have already discussed about the homologous series. Over there, we have discussed so the simple functional group, one type of functional group, they are possessing the same properties also. So generally, we will see a similar type of chemical properties and a gradation in the, you can say, homologous series, which means all the alcohol are there, they will possess the gradation of their chemical property, physical properties, which means they are possessing somehow a similar physical and chemical properties. So these two molecules, they are possessing the same molecular formula. Is this thing clear or not? Molecular formula is same, but their like structure is we can say different. Their like orientation is different. So and properties also, I have told you that this is different. So if we get into detail, what is an isomers? So those compound which possess the same molecular formula is same. This is the necessary condition. And what should be different over here? The number one thing that should be properties of these two groups. Same molecular formula but different properties. They must possess the different properties. So like I have shown you in the previous slide, this compound 1, this compound 2, they both possess the different properties. So if they are having different properties, so we can think that these are different isomers, and this phenomena is known as isomerism. And the another way is like arrangement of atom. The second criteria you can say arrangement of atom or molecule. Arrangement of atom and molecule in a compound. If there is some compound and that consists of the same two different compounds are there and they are possessing the same molecular formula but different properties, or arrangement of atoms or molecule in a compound is different. If any of these properties, either this thing or either this thing is different and they are possessing the same molecular formula, such type of compound, we can say that they are isomers of each other. And the phenomena is being termed as isomerism. So again coming back to this, so again we will be discussing the same example, C4H10O. So in this example of C4H10O, the molecular formula same, but structural formula is different. We will see like this. So if we are seeing over here that the arrangement of atom, see, both are possessing the C4H10O, molecular formula is same. Arrangement of atom, over here CH3 same, then CH2, then CH2, and after CH2 we can say the arrangement is like this. Arrangement of atom, you see oxygen, and over here we are seeing carbon, and again this hydrogen is linked with hydrogen, but this oxygen is one side linked with this CH2. So this is the way how we can differentiate that these two compounds are this one is and this one, these both are isomers of each other. These are isomers of each other, and the whole phenomena, how we are understanding this thing, that is being termed as isomerism. This thing. So now this is not like just one slide. We can just go through it, and we are going to understand the whole concept of this. So it is a very vast topic, and I will show you how many type of this you can say isomerism are there. So if you see, classify this isomerism. We will see generally we are dividing this isomerism into two major classes. Firstly, I have told you the isomerism, the basic concept of isomerism, molecular formula same, arrangement of atom different. Yes or no? Molecular formula same, arrangement of atom, how it is being arranged, we are going to see in the quite detail. So and the properties are like different. So that thing I've shown you, the properties are different sometime. Yeah, there is a difference in their properties. So like so now there are two type of you can say isomerism are there. The major dividation of this isomerism, the two subclass are there. This side structural isomerism and this side stereoisomerism. Structural isomerism and stereoisomerism. Structural isomerism and stereoisomerism. So what is the major difference between these two major subclasses over here? So we will see molecular formula same. Yes. The necessary condition is arrangement of atom. Same. Yes. So now what we are going to see over here, here we will see the attachment is same or different, which means the different atom, how they are being attached. We will be seeing over here. At the initially, the both things are same. That is like common thing for both. But when you come over here, we will see attachment different in this class. And in this class, we will see attachment different, sorry. And over there, the space is also not that much. So we are going to write over same, yeah? That is better or not? Yeah. Tell me. Attachment over here is same. Stereoisomerism. So molecular formula same. Attachment is also same. I will show you in quite detail how this attachment I am talking about. And here the attachment is different. I have shown you quite differently. Here it is quite obvious that this structure and this structure is very different. Clear or not? Here the structure is like this. In this the structure is quite different. But when you come over here, here the attachment is different. Yes or no? So this is an structural isomerism. This is an structural isomerism because I have shown you attachment is different. Why? Because attachment is different. Clear or not? So yes, coming back again, yeah. So yeah, attachment different. So I have shown you the example also. Many more example we can take over here. Like if we are having this chain 1, 2, 3, 4, 5, 6, and we are having another isomers 1, 2, 3, 4, 5 like this. So now if you see both these compound, they are having molecular formula of 1, 2, 3, 4, 5, 6. C6. How many hydrogen? C and H2n plus 2. 14 hydrogen are there. 3, 3, 6, 2, 4, 6, 8. 8 or 6, 14. So C6H14 is the molecular formula for both. Here 3, 3, 6, 3, 9. 2 or 9 or 1, 10 or 2, 12, 13, 14. So again 14, C6H14. So both are having the same molecular formula, but the structure is different. And you can say the attachment is also different. If structure is different, that is like you can say arrangement of atom is same. Yeah. Okay, I think I'm making a mistake over here. No one is telling also, yeah. Arrangement of atom is different. Then only we can say these are like isomerism. Otherwise, what is the difference? If no arrangement is different, yeah. So attachment is different in this structural isomerism, and this attachment is same. So these are also called as like structural. We can say in simple word, if you are getting confused at this moment, what is this attachment? You can just simply see the structure is different, structural isomerism. The structure is not different, and they are isomers. They are termed as stereoisomers. Clear or not? Not get into the detail of this attachment. So maybe you are getting so much pressure. Oh, today I am studying the first time isomerism. I am getting this much confusing terms like attachment, arrangement, like this. So at this moment, we will clear up all these terms in the next upcoming lectures when we will discuss the quite detail regarding this stereoisomerism. Over here, we will study regarding the 3D structure, how this carbon is there, how the attachment is there, how their arrangement is there. So then we will understand this concept in quite detail. So it will be better just if you are getting confused, then you can just think structure is different means structural isomerism. Structure not different and they are isomers, then that is stereoisomerism. Clear or not? This is the example I have shown you. So now if I want to more give some more subclasses of this, these stereoisomerism can be of two type. Again, these can be of two type. One is configurational isomerism and another is conformational isomerism. And second one is conformational isomerism. So these two type of isomerism are there. So again, if you get into the detail of this configurational and conformational also, this configurational can also be again into optical isomers and optical isomerism and geometrical isomerism. These optical isomerism can be again of two type, enantiomers, diastereomers, like this. So this way we are going to see regarding this, and this geometrical isomers again you will see most of the time cis trans isomers and many more subclasses we are going to discuss regarding this stereoisomerism. So it is a bit, you can say, not I am not making you depressed, but this is a bit complicated. Isomerism, stereoisomerism at this level, I don't think that you are going to understand this. I will provide this thing with some model thing, then you will understand them in a better way, like how the structure of CH4 is there, like I have already mentioned in the previous class also. One hydrogen this side, another hydrogen at that side, and two hydrogen are below side like this. So this is the way how these hydrogen are being attached, and this orientation different in the orientation. So if you see over here, the main difference between over here will be orientation. So what will be the main thing over here? Their attachment will be same, but their orientation will be different in 3D. Which orientation? 3D orientation. So the in 3D we are going to study. So like configurational and conformational. So this how like we will see regarding sawhorse, you can say, or you can say Gauche conformational isomerism, and we are going to see over here skew, eclipse. So many more conformational isomerism we are going to see over here. And here also I have explained you that this type of different isomerism are we are going to see in this stereoisomerism. So regarding this structural isomerism, We are having 5 classes generally. The first one is, you can say, chain isomerism. So those compound which are having same molecular formula, different structural formula, in the subclass of this only coming over here, yes or no? So what is the now the different in structure which is causing, which means the chain is causing the structure to be different, which means in this we are going to see the different in chain. The chain will be different like this. One chain is like this, and another chain is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Both the chain are different. Can you see or not? The main chain is different. Over here, the main chain is this one. And over here, the main chain is this one. So can you see the difference in the chain is giving rise to this isomerism? One, two, three, four. 1, 2, 3. Different chains are there. Clear or no? Different chains are there or not? So when the chain is different, that type of isomerism given rise by the difference in the chain are termed as chain isomerism. So we will discuss all these isomerism, chain, position in quite detail or separate wise. Just I am giving you uh, a brief view about all these isomerism. The second one is position isomerism. So what is special about this isomerism? So if you see this position isomerism, we will see over here the position of a group is going to change. And what is the group over here? That is going to be either our functional group, our multiple bond, substituent, if any of these like multiple groups, functional group, substituent, their position is changing. If their position is changing, that type of isomerism is known as functional group, positional isomerism. Like we are having C, 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 C. This is alcohol over here, a functional group. 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. And we are having OH at this position, 1, 2, 3, 4, 5. So in the both cases, we can quite easily see that this alcohol and this alcohol, their main chain is same, 5 carbon chain, and here also a 5 carbon chain. The difference in the position is the position of alcohol, which is a functional group. Again, if you see over here, double bond at this position, double bond at this position. So these are also a functional group. 1, 2, 3, 5. 1, 2, 3, 4, 5. These are the difference in the position of this double bond, say with triple bond, and some other more. We are going to discuss this also in quite detail regarding the position isomerism. So the next one is functional group isomerism. This thing we have already discussed in the previous, in the initial, when we have discussed the isomerism term. Then only I've shown you the difference in the functional group. When there is a difference in the any compound which is having the same molecular formula, but and the same different structural formula on the basis of the functional group. So like OH, like this. So these two are, it is alcohol This one is ether, and they are functional group isomers. Some more, it's not like this one. This is ketone and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Clear or not? So these are also having same molecular formula. Now we are going to discuss these also in quite detail. This is ketone, this is aldehyde. Many more examples. So these two are functional group isomers. The molecular formula is same. 5 carbon, 5 carbon. 1 oxygen, 1 oxygen. 3, 3, 6 to 10. 3 or 1, 4 to 6 to 8 to 10. So the molecular formula is same. The structure is different due to the change in the functional group. Over here ketone and this side aldehyde. Over here alcohol, ether, and many more examples. We are going to see how many numbers of this you can say isomerism, that also we will see in the upcoming slides or upcoming videos. So after that, one more type of isomerism is subclass of this ring chain isomers. Ring chain isomerism, in which if we are having a cyclic chain and another is like this, 1, 2, like this. So this is a ring and this is a chain. So the ring, this is a sub, you can say sub part of functional group isomerism only, where the conversion is from ring to chain, chain to ring. Such type of isomerism is known as ring chain isomerism. It is a subclass only of this functional group isomerism. So now two are remaining, like metamers and tautomers. So these metamers are such type of isomerism which are having same molecular formula, different structural formula on the basis of different in the alkyl position at polyvalent functional group. Polyvalent functional group. This type of compound show this metamers are polyvalent functional group. With that functional group that can be attached with more than one carbon chain, like ketone. This is ketone. This can be attached to two type of group. This side 1 carbon, this side 2 carbon. Clear or not? So this is an example of metamers we can see over here. And regarding this one and this one, are they metamers? Yes or no? So it looks like they are metamers. Yes or no? I will show you. Okay. Oh, I made a mistake. Yeah. This one and this one, they look like a metamers, but actually they are nothing. They are same compound only. This thing we are going to study in the stereo thing, because over here the numbering will be like 1, 2, 3, 4. 1, 2, 3, 4. They are methane, ethane, propane, butanone. This all thing we will study in the detail. Butane, 2-one. Both are having the same name, so they are same molecule. This one and this one, they are quite same. So for a compound to be metamers, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now they are metamers. Position of ketone is changing. For ether, position of ether is changing. So these are like metamers. When a polyvalent, these are polyvalent functional group. When the position is being changing, that are termed as metamers. And many more examples like thioether, or you can say secondary amine, tertiary amine, and many more example we are going to see over here of these metamers. and the last is tautomerism. This is very, very interesting and very, very important from the exam point of view of JEE, NEET, etc. So this is very, very important and conceptual, you can say, isomerism, and that's why generally we study this not in the basic organic chemistry. We study this in separately in a general organic chemistry in quite detail, where the movement of electron, how the electron is moving. So just I will show you one thing. This is one compound and this compound. This is keto and this is enol. And these both they exist in the equilibrium, and one is keto, another is enol, and this type of isomerism giving rise to two different compound, and how this keto and enol, which is stable, which is unstable, or comparatively at what are the factors which are affecting the stability of keto group. Sometimes we will see enol is in higher concentration, sometimes we will be the concentration of keto is more. That is will be based on like some electronic effect, some substituent effect, so many more things, hydrogen bonding. So that all these concepts like we are going to study in the upcoming lectures and GOC, like electronic effect, isomer effect, electromagnetic effect, all these effects we will study. So it would be better if we study this isomerism afterward. The rest all which we have discussed, we will be discussing in the next upcoming lecture, except this you can say all the structural isomer we will be studying in the next lecture, except the tautomerism that we will be studying in the you can say GOC part. That's all for today. Thank you everyone.